Imagine finding out that, well, almost stubborn mysteries in modern astrophysics, the invisible dark energy just aggressively pushing our galaxies apart, the phantom dark matter holding their spinning edges together, and even the bizarre initial conditions of the Big Bang itself.
Right, the big three.
Yeah, exactly. Imagine if you found out those aren't actually separate problems at all. Imagine if the entire cosmological crisis we've been stuck in for the last 50 years is simply the result of an error in one foundational fraction in Albert Einstein's relativity.
It forces a complete paradigm shift.
Hmm.
We've spent decades bolting these new unseen particles and exotic multidimensional forces onto the standard model, really just to keep the math from collapsing.
Like mathematical band-aids.
Exactly, yeah. The entire theoretical physics community has been stuck in this cycle of adding complexity to patch the holes in our standard cosmology. And then, this paper comes along that suggests we don't need a multiverse, we don't need undetectable ghost particles, and we don't need string theory.
We just need to change how we define the space between objects.
Yes, just completely redefine the void.
And that brings us to our focus today. We are doing a deep dive into a groundbreaking 2026 theoretical framework by Daryl Murphy, and it's called HIRS, which stands for Harmonic Interference Relational Spacetime.
Right.
The mission of this deep dive is to unpack this specific mathematical swap without drowning you in jargon. We are going to look at the mechanics of taking a universe based on the idea of solid objects moving through a cold, empty vacuum and replacing it entirely with the universe functioning as a vibrating quantum lattice.
A space where basically everything is defined by ripples of interference.
Exactly. So to understand this massive cosmic shift, we first have to zoom all the way into the smallest possible scale, right? We need to look at the cosmic speed limit.
Yeah, the transition from standard kinematics to this relational wave mechanics is where this whole theory begins. To really grasp the implications Murphy is laying out here, we have to look at the bedrock of standard relativity.
Which we've relied on for over a century.
Right, since 1905. Our entire conception of the cosmic speed limit has been dictated by the Lorentz factor. That's the equation dictating how time dilates and length contracts as an object accelerates toward the speed of light. And the engine of that Lorentz factor is the fraction v squared over c squared.
Velocity squared over the speed of light squared.
Exactly.
Which, that makes intuitive sense if you view the universe as a giant empty box, right? Velocity is just your speed through the void. But Murphy's paper argues that v squared over c squared is fundamentally a shadow of what is actually happening.
A macroscopic illusion, essentially.
Yeah. HIRS proposes striking that fraction entirely and replacing it with I over t. So we need to break down the physical mechanism of this new fraction. If we are throwing out velocity and light speed from the core equation of relativity, what physical reality do I and t actually represent?
This is where we move from a void to a plenum. The term I stands for destructive wave overlap interference, and t is the harmonic temporal cross-section of a local point in spacetime.
Okay, that's a bit heavy.
Let me break it down. HIRS argues that spacetime is not an empty background stage. It is a dual-field quantum plenum. You can sort of conceptualize this as a discrete harmonic lattice at the Planck scale.
So really, really small.
Unimaginably small.
Yeah.
Every single coordinate, every microscopic point in the fabric of the universe is the center of its own oscillating waveform. So the universe is this continuous humming matrix of overlapping fields.
Okay, so if I apply a fluid dynamics analogy here, standard physics treats two objects in space like two perfectly smooth, frictionless rocks flying past each other in a total vacuum.
Right, they don't interact with the space itself.
Yeah, their motion doesn't affect the space between them, but in a dual-field quantum plenum, there is no vacuum. Space is the medium. So those two objects are more like two distinct sets of multi-directional ripples expanding in a three-dimensional pond.
Oh, that's a great way to picture it.
And as the centers of those objects move relative to one another, their respective wave patterns crash into each other, they interact, and when waves interact out of phase, they cancel each other out.
Yes, destructive interference.
Right. That cancellation, that specific geometric phase mismatch, is the destructive interference, the I in our equation. Wait, so is motion just an illusion caused by waves interfering with each other?
Well, motion is real, but its consequence is purely relational. The pond analogy captures the geometry perfectly, especially that cancellation aspect.
Okay.
Because the t variable, the harmonic temporal cross-section, that represents the baseline, undisturbed overlap when 2 points in this lattice are entirely stationary relative to one another. They share a maximum temporal existence.
They're perfectly in sync.
Exactly. But the moment relative motion is introduced, you shift the phase alignment, the waves misalign, destructive interference, the eye increases, and you literally chip away at that shared temporal cross-section.
Wow. The implication there is that time dilation, like the literal slowing down of a clock on a fast-moving ship, isn't just some geometric rule handed down by relativity.
No, it's a physical process.
Motion is physically shredding the shared temporal baseline between the ship and the observer. As you move faster, your wave patterns clash more violently with the background plenum.
That is the physical mechanism underlying relativity in the HIRS model. In standard models, time stretches because the geometry of spacetime demands it algebraically to keep the speed of light constant.
It's just a math trick, almost.
Right. But in HIRS, time stretches because the fundamental harmonic existence of the moving object is physically being canceled out by destructive interference from the surrounding lattice. As your relative velocity ramps up, the value of I grows.
And it eats into t.
Yes. When I approaches the value of t, the destructive interference is almost entirely consuming your temporal cross-section. So the fractional overlap shrinks toward 0.
And if you chart that decay, it produces the exact identical curve as the standard Lorentz factor.
Flawlessly.
As I approaches t, the mathematics mirror an object approaching the speed of light. So at light speed, I equals t. The waves completely destructively interfere, and the shared temporal timeline collapses entirely.
You completely decouple from the shared light cone. The mathematical elegance here is striking, really, because I and t are both areal quantities. They deal with structural cross-sections in the plenum.
Oh, so they have the same units.
Exactly. Therefore, the ratio I over t is naturally a dimensionless fraction. We don't have to artificially square the terms to make the units cancel out, the way Einstein had to, with v squared and c squared. The physical geometry naturally dictates the mathematics.
That shifts our entire understanding of what motion is. It is entirely relational. But, this logic brings up a fascinating question, really a paradox.
Which one?
If motion causes these waves to crash and interfere, and that interference altered the fabric of time and space, what happens when you hit the brakes completely and sit perfectly still? If I take an object in this plenum and freeze it perfectly, eliminating all velocity, the wave interference should drop to 0, right?
And that exact paradox is what breaks open the field of modern cosmology here. In Section 2 of Murphy's paper, we encounter Postulate 4, which introduces the mandatory minimum interference floor.
Mandatory minimum.
Right. Mathematically, it's expressed as I-min is greater than 0. The framework dictates that perfect, flawless stillness is physically and mathematically impossible in a quantum lattice.
Wait, really? Is that because of the uncertainty principle? Like you can never perfectly define both the position and momentum of the lattice points?
The uncertainty principle plays a role, sure, but it's deeper than that within the dual field mechanics. The background fields of the plenum are continuously engaged in zero-point quantum fluctuations.
Just constantly buzzing.
Exactly. There is a relentless, unavoidable residual jitter baked into the fabric of reality itself. Because of this intrinsic harmonic vibration, you can never achieve a state where your local waveform perfectly aligns with the surrounding plenum.
There's always a mismatch.
Always. There will always be a fractional non-zero phase mismatch. Therefore, the value of I can never actually reach 0. There is a floor.
Oh, wow. Let's highlight why this is just mind-blowing. If we follow that logic, a mandatory minimum interference floor fundamentally alters the vacuum of space.
Okay.
Because if destructive interference physically erodes temporal cross-sections and interacts with the lattice, an inescapable baseline of interference means there is an inescapable baseline of tension.
Yes.
That means there is a perpetual positive vacuum energy baked into the fabric of the universe itself. We are talking about the physical origin of dark energy.
The implications for dark energy are monumental here, because let's look at how standard cosmology handles this. The cosmological constant problem is arguably the most embarrassing miscalculation in physics.
It's famously bad.
It is. When theorists use standard quantum mechanics to calculate the energy density of the empty vacuum, the resulting number is approximately 120 orders of magnitude larger than the gentle cosmic expansion we actually observe.
Right, 10 to the power of 120. They calculate an energy so dense it would have ripped the universe apart into solitary subatomic particles fractions of a second after the Big Bang.
Which obviously didn't happen.
No. So to fix it, they manually subtract a massive arbitrary number, fine-tuning the equation down by that factor of 10 to the power of 120 just to force the math to match what our telescopes actually see.
It is the ultimate ad hoc mathematical band-aid. But HIRS derives the observed dark energy density without a single arbitrary fine-tuning parameter.
That is huge.
It really is. The dark energy isn't some mystical new scalar field acting in the background. It is the direct, unavoidable geometric consequence of the Iman floor. Because the discrete points in the quantum lattice can never sit perfectly still, they constantly generate a trace amount of destructive interference.
A constant friction.
Exactly. This persistent phase mismatch acts identically to a stress energy tensor. It generates a continuous outward topological pressure.
And the paper explicitly maps this to the observable universe, defining the global time axis as gently curved. Murphy calculates the curvature radius of this global time axis as r is approximately c over h0.
Where h0 is the Hubble constant, right?
Exactly.
That specific geometric conversion is vital. The theory takes the ratio between the hypermicroscopic Planck scale jitter and the macroscopic Hubble scale of the observable universe.
Bridging the tiniest scale and the largest scale.
Exactly. By mapping the Iman floor through that geometric ratio, the framework outputs a predicted background vacuum energy density of exactly 5.4 times 10 to the negative 27th kilograms per cubic meter.
Which lands perfectly on the observed value. No fine-tuning required. It's pure geometry. We get the exact right amount of dark energy strictly from the fact that the spatial lattice cannot be totally silenced.
It transforms dark energy from this unexplained phenomenon into a mandatory structural feature of relational spacetime.
Okay, so the universe has this built-in geometric push. But looking out into the cosmos, astronomers have realized this push isn't behaving the way our old models predicted, which is leading to a massive crisis in physics.
You're talking about the Hubble tension.
Yes, the Hubble tension. Anyone following astrophysics knows that standard cosmology has been bleeding out because of this specific discrepancy. When we measure the expansion rate of the early universe using the cosmic microwave background, we get a rate of roughly 67 kilometers per second per megaparsec.
Right.
But when we measure the late-stage universe, like looking at local supernovae, we get a completely different expansion rate, around 73 or 74. It's like measuring a car leaving a starting line at 30 miles per hour, checking your radar gun later, and it's doing 50 miles per hour. But the standard model of physics insists nobody is stepping on the gas pedal.
That's a perfect way to phrase it. The discrepancy has pushed well beyond the threshold of statistical noise. It is a 5 sigma crisis.
Undeniable at this point.
Completely. The standard cosmological model relies on dark energy being perfectly rigid. Its equation of state, denoted as W, is assumed to be exactly negative 1.0 across all of cosmic time.
Never changing.
Right. If W is constant, the expansion measurements from the early universe and the late universe should seamlessly align. The fact that they don't strongly indicates that dark energy is dynamic. It is evolving.
So how does the HIRS framework handle dynamic dark energy? Because if the Iman floor is a constant geometric feature of the lattice, how does the resulting outward push change over billions of years to create this Hubble tension?
The solution lies in how the interference floor interacts with the rest of the quantum ecosystem. Murphy introduces the concept of a thawing dilaton.
Thawing, okay.
Yeah. The baseline interference floor, Iman, doesn't exist in a vacuum. It physically couples to the Higgs field, the field responsible for giving particles mass, through a background scalar field known as the dilaton.
So the stiffness of the dark energy push is tied to the local vacuum expectation value of the Higgs field.
Precisely. In the incredibly dense, hot environment of the early universe, this coupling is tightly constrained. The dark energy behaves almost identically to a rigid cosmological constant.
It's frozen in place.
Exactly. But as the universe expands, cools, and the matter density drops, the dynamic tension between the dilaton field and the Higgs field begins to shift. The equation of state of the vacuum energy slowly increases, or thaws, moving slightly away from negative 1.0.
So the push becomes slightly more potent at late times. The background lattice fundamentally softens as it expands, allowing the residual jitter to exert slightly more influence on the cosmic scale.
You got it.
And that directly bridges the gap between the data from the early universe and the supernova data from today.
And, this isn't just theoretical convenience. This aligns directly with the blockbuster data we saw from the Dark Energy Spectroscopic Instrument, the DR2 measurements from March 2025.
Oh, right. That was a huge deal.
It really was. That survey mapped the expansion history of the universe with unprecedented precision and found strong indications of mild time variation in dark energy.
Which blew everyone's minds.
Right, because the standard model had no mechanism for a varying dark energy that didn't break other established physics. But HIRS models this exact late-time thawing behavior using only a single dimensionless parameter, lambda, which naturally modulates the Iman coupling.
So it fixes the biggest headache in modern astronomy with one parameter. It's an incredibly robust chain of logic. We swap velocity for wave interference, the impossibility of zero interference gives us a baseline vacuum energy, and the coupling of that energy to the expanding fields naturally recreates the exact cosmic acceleration we see today.
It covers all the bases.
But, okay, mapping the expansion of the universe only addresses the void. Let's look at the structure. Standard physics is equally dependent on dark matter to explain how galaxies form and hold themselves together.
Right. Dark matter is the missing gravitational mass.
Right.
We see galaxies rotating at speeds that should fling their constituent stars into deep space, given the amount of visible matter they contain. The rotational curves are completely flat.
They shouldn't be holding together.
Exactly. So to explain the extra gravity holding them together, standard physics assumes the existence of a vast halo of invisible, non-interacting particles surrounding every galaxy.
Let me play devil's advocate and push back on the particle physics community here. Scientists have spent decades and billions of dollars building massive underground detectors, looking for dark matter particles like WIMPs. Is HIRS suggesting they are hunting for ghosts?
Yes. It entirely abandons the particle hypothesis. In HIRS, dark matter is an illusion created by collective resonances in the dual-field quantum plenum. It requires absolutely zero new fundamental particles.
Zero.
None. The framework explains the missing gravity through what Murphy defines as collective resonances.
Okay, so if the plenum is a humming, vibrating matrix of overlapping waveforms, we can look at acoustic fluid dynamics. When you have waves propagating through a medium, they reflect, they overlap, and they form standing waves, right?
Yes.
They create complex harmonic interference patterns where the localized energy density of the medium is significantly amplified.
That is the exact mechanism. These localized zones of amplified wave overlap act as gravitational echoes.
Gravitational echoes.
Right. Remember, in general relativity, gravity isn't just generated by mass. It is generated by localized energy density and pressure, the stress energy tensor.
Right.
The concentrated harmonic resonances within the space-time lattice physically warp the local geometry just as heavily as physical mass would. They exert a gravitational pull on ordinary matter, but because they are purely structural deformations of the lattice, they do not interact with the electromagnetic field.
Meaning they emit no light.
Exactly. They emit no light, they absorb no light.
They mimic pressureless dust perfectly. But if these harmonic standing waves are an inherent property of the plenum, why do they form the specific cosmic web we see today? Like, why did these resonances just instantly clump up and crush the universe into black holes a millisecond after the Big Bang?
That requires us to look at the thermodynamic history of the cosmos. In the radiation-dominated era, immediately following the Big Bang, the universe was an intensely dense, hyper-energetic plasma. The radiation pressure was overwhelming.
Just a chaotic mess.
Right. This immense chaotic kinetic energy effectively suppressed the formation of stable, large-scale harmonic structures. The resonances were washed out by the sheer violence of the ambient radiation.
So the acoustic standing waves couldn't anchor themselves. But that changes at the epoch of recombination. Roughly 380,000 years after the Big Bang, the universe undergoes last scattering, right?
Yes, exactly.
The temperature drops enough for the first neutral atoms to form, the plasma clears, and the primordial photons decouple and fly free, which is the cosmic microwave background we observe today.
The sudden drop in radiation pressure is the catalyst. Without that oppressive background radiation violently disrupting the lattice, the subtle acoustic echoes, the plenum resonances, were free to stabilize.
They finally had room to breathe.
Exactly. They rapidly became dynamically dominant, acting as the invisible gravitational scaffolding that pulled ordinary primordial hydrogen and helium together to ignite the first stars and shape the earliest galaxies.
This sounds incredibly elegant, but physics requires hard data. Dark matter isn't just a generic pull, it has specific clustering behaviors that we measure through the matter-power spectrum. Does this acoustic resonance model actually map to the real-world distribution of galaxies?
It maps with startling precision. Because the resonances are a product of harmonic wave mechanics, they should possess a specific structural wavelength based on the fundamental properties of the plenum. The paper calculates the exact co-moving clustering scale of these dark matter halos.
And what's the number?
It predicts a value where the resonant wave number, K Arrhenius, is approximately equal to 0.1 h per megaparsec.
A co-moving scale of 0.1 h per megaparsec. If that specific wavelength is structurally dictating where gravity pools, it should leave a distinct mathematical fingerprint, a literal bump in the statistical distribution of galaxies across the night sky.
Yes, and it does. When cosmologists analyze the vast galaxy distribution maps generated by the BAW-SS and the DTSI spatial mapping projects, they plot the matter-power spectrum. The standard cold dark matter model struggles to perfectly fit certain subtle deviations at specific scales.
But HIRS fits it.
Perfectly. HIRS predicts an exact mathematical bump at the 0.1 h per megaparsec scale. The observed clustering patterns from the real-world DDSI and BOSS data trace this harmonic fingerprint seamlessly. The galaxies are literally sitting in the acoustic troughs of the spacetime lattice.
Which means the detectors buried under mountains are hunting for a particle that doesn't exist. They are trying to catch a physical object when the gravity is actually coming from the architecture of the void itself.
Precisely.
Let's push this architecture to its absolute limit. We just talked about the universe cooling down. Let's rewind the clock all the way to the very beginning, the Big Bang, where the standard rules of physics usually melt down.
The Genesis moment. The early universe is where standard physics famously breaks down, generating three persistent paradoxes: the horizon problem, the flatness problem, and the monopole problem.
Right, and we all know that standard cosmology uses cosmic inflation to solve these. It assumes that in the first fraction of a second, an entirely new, unobserved field, the inflaton field, caused the universe to expand exponentially faster than the speed of light.
Just massive, sudden expansion.
Yeah, smoothing out the temperature, flattening the spatial curvature, and diluting any massive primordial magnetic monopoles. But inflation is theoretically messy. We have no idea what caused it, how it started, or why it stopped so perfectly. So how does HIRS explain the uniform temperature everywhere without relying on an ad hoc burst of exponential expansion?
It tackles the underlying assumption that causes the horizon problem in the first place. The assumption that the speed of light has always been a rigid constant.
Oh, wow.
Yeah. The HIRS framework proposes the high chi epoch. Remember the Dalton field, denoted by the Greek letter chi, which we discussed in relation to the thawing of dark energy?
Yes, the coupling field.
Right. In the unimaginably dense, hyperthermal environment of the primordial universe, this scalar field was not relaxed. It was incredibly elevated.
And the mathematical core of HIRS states that the effective speed of light, CSEF, is directly proportional to chi to the 1/2 the square root of the dilaton field.
Exactly. Because the chi field was wildly elevated at the moment of the Big Bang, the effective speed of light in the early universe was astronomically higher than the 299,792 kilometers per second we measure today.
If the speed limit of causality itself is fundamentally multiplied, the entire concept of the causal horizon shifts.
Drastically.
The horizon problem exists because two opposite edges of the observable universe are the exact same temperature, but there wasn't enough time at the current speed of light for them to ever physically interact and equalize.
Right.
But if the effective speed of light is trillions of times faster, it's like a mixing analogy. Imagine trying to mix a giant swimming pool of paint to a perfectly uniform color in 1 second with a tiny spoon.
Impossible.
Totally impossible. But if the spoon's speed limit suddenly becomes trillions of times faster, you can stir the whole pool instantly. The causal communication sphere is vastly enlarged.
That's a perfect way to visualize it.
Yeah.
You don't need the physical space to violently inflate to smooth things out. You just need the thermal information to travel fast enough to mix the system. The high chi phase organically guarantees a perfectly uniform background temperature.
And the same logic applies to the flatness and monopole problems, right?
Yes.
If the effective speed of light dictates the relational geometry of the lattice, an astronomically high speed naturally stretches out any initial quantum curvature, driving the topology toward the perfect flatness we observe today.
Exactly.
And if super heavy magnetic monopoles were forged in those initial extreme temperatures, the rapid dynamic expansion driven by that elevated speed of light naturally disperses their density.
Finding a monopole today in our local observable patch would be a statistical impossibility. The beauty of the high chi epoch is its phase transition. As the universe expands and the global temperature drops, the chi field naturally relaxes.
The speed limit comes down.
Right. It undergoes a smooth transition, gradually dropping the effective speed of light down to the baseline value we observe in the modern cold universe. It cleanly leaves behind a flat, uniform cosmos without requiring a mysterious temporary inflating field.
There is an incredibly nuanced detail buried in this section of the paper regarding the initial state of the lattice that addresses one of my favorite mysteries: the matter-antimatter asymmetry.
Ah,
The
yes.
Standard Model says the Big Bang should have created equal parts matter and antimatter, which should have mutually annihilated, leaving a universe filled only with light. But we exist. There was a tiny bias, one extra matter particle for every billion antimatter particles. How does the interference floor factor into that?
This is where the physical geometry of the lattice provides an elegant solution to particle physics. Because the Eiman floor, that mandatory residual phase mismatch, has existed since the absolute beginning, the fundamental baseline of the universe has never been perfectly symmetrical.
It's always been slightly off kilter.
Yes, that persistent geometric jitter creates a built-in topological bias in the dual-field plenum. During the extreme high-energy conditions where the first quarks were condensing out of the plasma, this intrinsic phase mismatch subtly favored the production of matter over antimatter.
It tips the scales.
Exactly. It provides a natural mechanism for CP violation charge parity violation that the Standard Model struggles to quantify organically.
So the fact that we have physical stars and planets, rather than just an empty void of photons, is a direct consequence of the fact that the quantum lattice cannot sit perfectly still. It's an astonishing synthesis.
It really is.
But, talking about manipulating the effective speed of light brings up the most radical, speculative, and frankly dangerous aspect of the Murphy paper.
Here we go.
If the speed of light isn't a rigid universal law, but rather a local property dictated by the state of the chi field, what happens if we build a machine to manipulate that field ourselves?
You are looking at the foundational mechanics of a faster-than-light drive. Section 6 transitions from astrophysics to speculative engineering. But before we discuss how a starship might traverse this plenum, we have to look at why HIRS makes the mathematics of localized field manipulation possible at all. We have to talk about how the framework tames the infinities of quantum field theory through natural renormalization.
Oh, right. Anyone who has studied quantum mechanics knows that renormalization is sort of the dark secret of the Standard Model.
It's a massive headache.
When you calculate the probability of particle interactions, especially at incredibly small distances or highly energetic states, the math often just explodes to absolute infinity. To get a usable answer that matches lab experiments, physicists effectively employ a mathematical trick. They introduce arbitrary cutoff points, essentially subtracting the infinite values to leave behind the finite result they need.
It works brilliantly for making predictions, but mathematically, it is deeply unsettling. It implies our equations are incomplete. But in the HIRS framework, renormalization isn't an arbitrary mathematical trick. It is a physical law dictated by the geometry of the lattice. We return again to the Eiman floor.
The minimum interference.
Right. Because destructive interference can never physically reach zero, it implies that the harmonic distance between interacting points in the plenum has a fundamental physical floor.
So the denominator can never reach absolute zero, meaning the fraction can never explode to infinity.
Precisely. The discrete nature of the dual-field lattice provides a built-in physical ultraviolet cutoff. The momentum sums and loop integrals in the quantum math naturally hit this structural bumper before they can reach the singular limits that generate mathematical infinities.
It radically cleans up the math.
It makes the system self-consistent and finite by default.
Okay, so if the math is finally stable and the effective speed of light is dictated by the local inner-field coupling, we can move to the speculative warp mechanics.
The fun part.
Yeah. If an advanced civilization wanted to travel faster than the baseline speed of light, they wouldn't try to accelerate a massive object through the lattice using brute force. They would build a localized bubble where they actively suppress the destructive wave overlap interference. By artificially dropping the local value of I, they elevate the local effective speed of light.
You modulate the chi field within a confined geometry. You aren't moving faster than light. You are changing the definition of light speed in your immediate vicinity, allowing you to ride the wave gradient through the plenum.
That is incredible.
However, Murphy's paper is highly specific about the required geometry of this warp bubble. It explicitly rules out the classic sci-fi trope of a spherical force field.
And I found the fluid dynamics explanation for this fascinating. Why does it insist the warp bubble must be ellipsoidal like a pill shape rather than a cool spherical bubble?
It comes down to fluid dynamics in the lattice.
Right. Think of a blunt, round boat pushing water. It creates a turbulent, destructive, resonant wake. An aerodynamic, elongated hull slices through the waves. If you analyze the interference track along the direction of motion in the plenum, it possesses a highly distorted sinusoidal character. Trying to push a perfect, blunt sphere through this harmonic matrix is a recipe for disaster.
A complete disaster. The boundary where the spherical warp bubble meets normal, unaltered spacetime would create catastrophic, resonant standing waves. The wavefront would effectively crash against the blunt leading edge of the sphere, generating destructive acoustic nodes that would exponentially feed kinetic energy back into the bubble.
Instantly vaporizing the ship.
Instantly. The physics demand an ellipsoid. A highly elongated, needle-like warp bubble aligns smoothly with the phase interference gradient of the surrounding lattice. It minimizes the total distorted volume and allows the harmonic wavefront to gracefully contract ahead of the vessel and expand behind it without generating those lethal resonant nodes.
The geometry must be aerodynamic with respect to the quantum wave matrix, not just physical atmosphere.
Exactly.
And this neatly skirts one of the biggest theoretical hurdles in warp drive physics. The famous Alcubierre metric from the 1990s proved warp drives were mathematically possible in general relativity, but they required massive amounts of impossible negative energy to contract the space ahead of the ship.
Which we've never found.
Right, leading to numerous no-go theorems. How does an ellipsoidal HIRS bubble avoid the negative energy trap?
By utilizing what the paper calls a Higgs dilaton modifier. Because the warp bubble isn't bending the macro fabric of gravity, but rather manipulating the scalar fields that generate the local interference ratio, the necessary negative pressure doesn't need to be imported from some exotic dark matter source.
It's generated locally.
Right. The negative pressure is supplied locally by forcibly shifting the vacuum expectation value of the Higgs field along the boundary of the ellipsoid. It organically satisfies the energy conditions within the localized area without violating the broader laws of general relativity.
But manipulating the vacuum expectation value of the universe's foundational mass-giving field comes with a terrifying safety warning. The paper outlines a very strict operational limit for engaging the drive.
The activation and deactivation phases are the most volatile moments. When you manipulate the Higgs dilaton coupling to alter the local speed of light, you are storing immense amounts of potential field energy in the boundary wall of the ellipsoidal bubble.
Like winding a spring.
Yes. According to the framework's calculations, you must ramp the field up or down at a very specific controlled rate. Exactly 0.25 to 0.4 seconds per unit of sea change.
Meaning, if you want to jump to 100 times the speed of light, the field must take at least 25 seconds to spool up to that configuration. What happens if the containment fails or you drop the field instantly?
The stored field energy in the bubble wall collapses back to the baseline lattice configuration instantly. That rapid phase transition would trigger massive Bremsstrahlung radiation. You would release a lethal, omnidirectional burst of hard gamma radiation and hyperionized plasma. It would completely vaporize the vessel and sterilize anything within several astronomical units of the collapse.
So a rather extreme consequence for stalling the engine.
Very extreme.
But the fact that this mathematical framework scales flawlessly from the Big Bang to galactic rotation curves, right down to the fluid dynamics of a speculative warp drive, is what makes the Murphy paper so compelling.
It's a unified vision.
We've covered an immense amount of ground today, but to close out this deep dive, we need to transition from theoretical elegance to empirical reality. Because a beautiful mathematical model is useless if it cannot be falsified.
Absolutely. The hallmark of a robust theory is testable predictions. By swapping out the kinematic fraction v squared over c squared for the relational interference ratio I over t, HIRS transforms our static, empty universe into a vibrating relational ocean.
Giving us dark energy from the interference floor.
Right, and dark matter from the acoustic standing waves. Plus a variable speed of light that solves the Big Bang. But Darryl Murphy doesn't just offer explanations for old data. He provides specific, measurable signatures that upcoming astronomical surveys must find if this theory is correct.
Let's lay out those specific predictions. What is the first major signature cosmologists should be looking for?
It concerns the supernova Hubble diagram. If the expansion of the universe is being driven by the thawing interaction between the interference floor and the background fields, that expansion shouldn't be a perfectly smooth curve.
Because of the waves.
Exactly. The sinusoidal nature of the foundational wave interference dictates that there should be a tiny, measurable rhythmic ripple in the expansion rate over cosmic time.
A physical heartbeat in the expansion of space-time.
Precisely. The paper predicts a roughly 7-cycle oscillatory residual across the observable redshift range. This ripple would have a tiny amplitude, roughly at the 0.1% level,
Very subtle.
but measurable. If astronomers take the vast data sets from the supernova surveys and reanalyze the light curves looking for this exact 7-beat harmonic oscillation, and they find it at that 0.1% threshold, it would be an irrefutable validation of the harmonic interference model. Standard cosmology predicts a perfectly smooth curve. Only HIRS predicts the ripple.
And the second major prediction targets the oldest light in the universe, the cosmic microwave background.
Yes. The phase-dependent interference across the plenum doesn't just affect expansion. It creates a global harmonic modulation across the entire topological structure of the universe. Because of this, the framework predicts that the largest scale temperature variations in the CMB, specifically the quadrupole moment, will be physically aligned with the cosmic dipole.
Which directly addresses the axis of evil anomaly in the CMB data that cosmologists have been arguing over for years. Standard theory claims the alignment of these hot and cold spots is just a bizarre statistical fluke.
HIRS claims it is a foundational geometric requirement of the lattice. Furthermore, the paper predicts the exact amplitude of that quadrupole alignment. It must be 8 plus or minus 2 microkelvin.
Wow, 8 plus or minus 2 microkelvin.
Yes, this is a highly specific, easily falsifiable number. As next-generation CMB observatory missions map the background radiation with higher resolution, finding that exact amplitude alignment would strongly indicate that our universe is fundamentally relational.
It fundamentally changes how we view our place in the cosmos. We have spent the last hour breaking down the physics of a universe that isn't made of isolated, lonely objects moving through an indifferent void. By swapping out that one fraction, if Daryl Murphy is right, everything is intrinsically connected.
Woven together.
An object only exists and time only flows in the specific way that its quantum waveform overlaps and interferes with the waves of the rest of the universe.
Existence is entirely dependent on interaction.
Which leaves us with a profound philosophical implication to consider. If the relational friction of your existence against the cosmic lattice is what physically generates the passage of time, what happens if you remove the lattice?
That's a terrifying thought.
If you were somehow placed in a true, absolute void, completely isolated from the cosmic plenum, with absolutely no other waves to overlap or interfere with, would you even experience the flow of time at all? Or would you simply be frozen outside of causality itself? Think about that the next time you look up at the empty night sky.